Assalamualaikum, my name is Nur Shaman Bichit Samsuriza. I will present about air conditioning in the coach. So for the introduction, air conditioning is necessary in order to comfort the passenger in the train, or we call as cabin. The temperature inside a train is an important factor in the passenger experience. For the overall design of the train, the manufacturer has to take a variety of data into account, such as the degree of sunshine and temperature of the line, the presence of tunnel, expected passenger numbers, and so on. What is air conditioning? The air conditioning is used to cool down the space by removing the heat from the space into the outside. The cool air can be separated or can be moved throughout the train by using the ventilation. So, how the air conditioning work in the cabin? The air conditioning work in 4 easy ways. So the first way is the ventilator suck in the warm air. Second, like in a refrigerator, a liquid refrigerant absorbs the heat. Third, the heat is rejected outside in the train. And the last is the cool air is released into the train interior in order to cool down the space in the cabin.
Assalamualaikum, my name is Nur Afzal. There are several usages of railway coach air conditioning system. First of all, the air conditioning system will supply clean fresh air at a controlled uniform temperature. The control unit of heating and air conditioning system usually placed on the roof to ensure the thermal comfort and the quality of air on board. Second, the fresh air confines in catering railway carriage to the continuously changing number of passengers. The air conditioning system provides for heating or cooling on a train depend on varying heat load to maintain specified temperature. Therefore, the train has to be adapted in different climate as warm and sunny regions during its journey. The operation of the equipment of air conditioning system is from power generated, then stored and controlled in the train. And here, I shows on how the air conditioning system in railway coach works. The air conditioning system works by 4 steps. Firstly, the ventilators suck in the warm air. Then, the liquid refrigerant absorbs the heat as same as applied in a refrigerator. The heat will reject to the outside of the train, while the cool air will release into the train interior.
Now I want to talk about the factor that influence the designing air conditioning system. This factor is important to give continuous comfort to passengers and workers. First is a climate. Climates can consider as difficulties during the train travel in order to keep the train cool and comfort temperature for passengers and workers. During the peak hour, the temperature in a coach also have a disturbance when the pupil move in and out from the coach. This sudden change temperature may cause chill or heat. So, in matter of hours, this system need constantly adapt to diverse climates. Second is heat loads. In a railway travel, hundreds of passengers can board and depart from the coach. There's a lot heat body come from a passenger. When a large number of people in a coach, it affects internal temperature. From this large number of passengers, it also affects the circulation air on coach, which make the circulation moves limited. So, for designing the air conditioning system, it is required to detect this heat load change and adjusting the temperature accordingly. The third point is speed. Trains nowadays is account as fast travel and fast transport to use for people. However, air conditioning system to high G-force which can affect the stability of coil and even cause them crack. For this purpose, the air conditioning system even equipped with the coils that will be able to withstand high G-force and intense vibration.
Assalamualaikum. My name is Muhammad Aziz. For the aircon calculation, for the unit refrigerant is a refer to in ton. It's a refer to the latent heat required to emit a ton of ice at 0 degrees C in 24 hours. For the information, we have 1 ton equal to 907185 gram and latent heat 334 joule per gram. To find 1 TR, the mass multiple by latent heat and divide by 24 hours. So we have 12624991.25 Kelvin joule per gram for the 1 unit. And then for the 1 unit ton in refrigerant can approximate to flow in 100 square feet. For the energy consumption, the SG coach holding itself generation coach AC 8000 and non-AC 40,000. So to find the installation of capacity of power generation, number of coach multiplied by generation unit, and AC coach 88,000 multiplied by 50 kilowatt and non-AC 40,000 multiplied by 4.5 kilowatt. For the total installation capacity, we have 580,000 kilowatt, and considering 55% on online availability and 80-hour coach working per day, so we have 783,000 kilowatt per day that using for the train. So 50% of the energy accounted in electric traction bill and balance on diesel traction. For the daily use is average for 100 coaching mail and express train operate per day. Therefore, they have average 985 unit of energy consumed per train per day.
In this part, we'll be looking at the end-on generation EOG of the air conditioning in coaches. Coaches with EOG provides the electricity for the hotel loads. Examples of hotel loads in coaches is fans, lights, pantry, and etc. Air conditioning is also part of the hotel load in the coaches. So the hotel loads being powered with electricity with the help of generator powered by diesel, and there are 2 units of this generator, the 2 sets of the generator being provided at each end of the train, giving it the name. EOG is only used for fully air conditioned coaches. 2 NOS 500 kilowatt DG at each end of the train. 100 liters per hour of oil being consumed in a trip. For example, a trip from Mumbai to New Delhi and back, with the 21 coaches being powered. The average consumption can be taken for a period of 10 to 12 trips, and the number is 0.25 for average oil consumption per kilowatt hour. This is based on 2 power cars and 400 units per hour, mainly for air conditioning load. This goes to good scope for energy conservation. Another fact is that when using EOG, air pollution and noise pollution can be reduced. Another way of keeping away the noise pollution and also the air pollution from the railways is to use the head-on generation HOG, in which it supplies the electricity from the overhead electric lines through the pantograph.
For the conclusion, we can say that the energy consumption by air conditioning cabin are higher than a normal cabin. Due to the large number of passengers in small cabin, the space left for the air circulation is limited. So we must use the space optimization and the power optimization in order to improve the air conditioning cabin.